Okay, so now that I have my packs built, my problem now is to charge them. This is half of the pack that's required to parallel into the Nissan Leaf. Now half of a Nissan Leaf pack is fully charged would be about 198 volts. So how do you cheaply charge 198 volts DC? Well, there doesn't seem to be any way to do it cheaply. So what I've decided to do for now is charge them in small parts. So here, from here to here, actually this is the reason I built it this way. 6 cells in series is a more manageable 24.8 volts. So I'll be charging these 6 and these 6 and so on and so forth, all up to the appropriate voltage of 24.8. And then once they're all charged, I should obtain a total voltage on this pack of 198. And once I put this one in series with my other pack, I'll get the 396 volts that I require to parallel in with the Nissan Leaf. Now, how do I do this? I do this using one of these. This is a DC to DC converter, which you can get on eBay for under $4 US. They can do 7 to 32 volts in to 0.8 to 28 volts out. So that's perfect. Now I need to power that up. To do that cheaply, I use a computer power supply, which is 12 volts. Now if I put two 12 volt power supplies, I would get 24 volts, which is under the 28 I require. So what I did is I got one of these. These are laptop power packs from an HP. These are what came with a docking station back in the day. They are 19.95 volts, 11 amps, so plenty of power. So the 12 volts in series with the 19, well, basically 20 volts, gives me 32 volts. So that's nice and above the 28 volts I require. So that's my input. These are, like I said, wires in series. I put they're hidden here. This is a diode, and there's a diode in here, just so that when I power them up, they can't backfeed and blow each other out. So these two in series go into the input, and then on the output side, I wired one of these cheap hobby watt meters. So currently you can see that I have 0 amps, 24.99 volts. So these are probably not very precise. My voltmeter is telling me I got 24.8, which is what I need. So now, if you follow the wire along, I've got these little connectors on. So these will be easy to clip on to the leads. You can see that. I'll be able to attach these easily and then move them along to charge them. So I'd charge I'll need to solder something here, but the negative and then the positive, and then charge the next series. Sorry, it's in 6. When you charge battery packs in series, you have to watch that they're balanced. So obviously these cells, they've been sitting around, some of them are obviously wouldn't be at the same voltage. So let's show you what I've done here. So on this pack, I connected balance leads using the same little connectors. They're all connected on each cell, and you can see these you can get from Hobby King. So they're under, I think, about $10. So I've got voltages going from 3.79 all the way to 3.89. So most of these cells should be around 3.8. That's what I've been charging them to. The one that is higher, I'm assuming it's because at first I used to use the IMAX clone to do storage mode, and its storage mode was a bit higher than what I wanted. So now that I The other ones are 3.8. So there's a balance function here. So if I do balance, it'll balance the cells. Right now if I hit balance, nothing's going to happen because I set the required voltage at 3.9. So they all have to be above 3.9 before it starts balancing. So what I'll do now is I'll connect these leads. So this is the negative, which I need to connect to the negative. And then the positive. It's hard to do this one-handed, but we'll get to it. So here we go. So if you look at here, the voltages have already climbed, and it's trying to balance the ones that are above. If I go back down here, we are charging at 2.8 amps roughly. I'll confirm this with my clip-on meter. So I'll just reset this. And I got to about 2.5 here. So that's good. These constant current, constant voltage, you can adjust the current output and the voltage output. So this so happens to be about where I would like it to be, 2.5 amps. I don't want to charge them too quickly. So there's two cells in parallel, so they're each getting a little over a 1 amp charge rate, which is fine. And so we'll let this go until it equalizes. Gradually the current should drop. And right now you can see it's getting to 24.5 volts. And so we'll let this go. Let's see what this looks like. You can see the lowest voltage right now is 3.98. Okay, so I'll probably let this go for roughly half a day. So I'll try to do one pack, well, 6 of them every 12 hours. So we'll give you an update once that's done.